So a little bit more about the vector search engine. So actually, what is a vector search engine and how does it work? What's different from a vector search engine opposed to a traditional search engine is that the vector search engine does not store its data in rows or columns or in a traditional graph, but it stores it in a space. And that space is based on a machine learning model. So if we look at that model, we see in that space all kinds of dots, and those dots represent individual words. So here you see all these purple dots, and here you see one single dot which represents a word, for example, iPhone. So this is an empty search engine. There's no data in there yet. It just comes with a machine learning model which represents these individual words. So if you look at another word which is close to iPhone, then you see that, for example, the word apple is nearby. Or you find the word fruit nearby. And what's important in these models is that Apple, of course, has a relation as a company to iPhone, but you can also eat an apple, so there's a relation to fruit. But the relation between fruit and iPhone is, of course, bigger. There's less relation between those two. So that's why they are further away, and this one is in the middle. And if you, for example, look at the word company, you can actually see, well, the word company, there's an apple, which is also a company. And there's a relation between the Apple, the company, and iPhone. So that's how this is structured. This is called word embeddings. So if you want to look that up, if you never heard of them, then if you just Google on word embeddings, you will find them. What you see here represents 3 dimensions, but in our data model, we use 300 dimensions, which sounds very fancy. But the reason why you use more than 3 dimensions is to give enough context. So one of the things to imagine that and how those dimensions work is, for example, if you go to a restaurant and you say like, well, you can have 1 dimension where you scale if food is salty or not. So then if you say, well, the food is, if it's very salty, you give it a 1. If it's not so salty, you give it a 0 or everything in between. And that would then be 1 dimension. So if you now say, okay, I'm also going to add sweet to the mix, then you have 1 dimension of salty, you have 1 dimension of sweet, now, etc., etc. So with these words, we've seen that 300 dimensions gives enough context in that space to make relations between these words. You can also look at concepts. So for example, here we have Stanley Kubrick, the director, and then nearby you might find something like 2001: A Space Odyssey, which is of course the movie that he created. So now what Weaviate does and what makes Weaviate different from traditional search engines is that if you have your data model, which we see here on the left-hand side, so here we see a class, and the class has a property, for example, name, or a property founded in, and you have the values, for example, Apple, a date, and has CEO, a person with the name Tim Cook. Then what Weaviate does the moment that you import the data in the search engine is that it takes that information and it creates an array of those individual words. So we have company, name, Apple, founded in, etc., etc. What it does with that context is that it funnels that down. And first, it calculates the distances in that space between those words. So you've seen the word company in the vector space. You've seen the word Apple in the vector space. So it looks up all these words, and it calculates the distances in between them. And then there's a function based on the occurrence, so that we say, well, the more often a word occurs, the less important it is. So, for example, the word in might occur very often in the training data set, but it's not very important. It doesn't say much, the word in. But if you look, for example, at the word Apple and company in combination, they are way more important and they occur less in the training data set. And then we have something which is optionally that you can actually boost words if they're very important. But the important thing is what it does with this is that it calculates a point in the center of all these words, as you can see here, and that has its own vector representation. And this is the important thing of Weaviate. So here you see an empty Weaviate again. And so what it does, it actually places that data object, as you can see here, in that vector space. And what you now can do is that if you search for data, but you don't know the keywords in the data object, so we say, for example, well, there's something, we look for company in iPhone, then it looks in the neighborhood which data object is there, and it will find that object. But maybe if you would search for Steve Jobs and Macintosh, you might also find this data object. Now that brings us to our data model. So we have a graph-like data model, which is based on GraphQL. And this is what it looks like. And when we do the demo, you will, of course, also see that in action. So what we do with Weaviate is that we use a Restful API to add data, but the GraphQL API to get data. If you're not familiar with GraphQL, I would highly recommend to check it out. We did not invent this query language. It's an existing query language. And this is syntax. So what makes it special for Weaviate is that we say, well, we have the action that we want to get things out. Then we make a distinction between things and actions that you can get from Weaviate. And then the schema that you can get out. And the schema is something that you create, which we also will see in the demo. So you can create a schema, for example, publication, and then you can have a semantic filter on it. So explore based on fashion, for example, and the name. So this query shows the names of publications, and it explores them based on fashion. Or if you have a data set with articles, you can say, well, give me things which are articles, and I want to see the title, but I want to explore them based on housing prices in Asia. Or if you want to even make it a little bit more complex, then you actually have the graph relation. So now you can create a traditional graph. So you can say, well, this article has a title and it's in a specific publication, which we will see in the demo. So that brings me to the demo. So if you go to GitHub, let's see if there's any question. Yeah, if you go to GitHub and you just type in Weaviate documentation, you can miss it because it's the first result. In the documentation, you can find the installation guide. So actually how you can install Weaviate. And we have a few options here. So we have Docker Compose, we have cloud deployments, we have a cluster service, we have Kubernetes. The cloud deployment, Docker Compose has a configuration tool. So you can say, well, I want to, for example, these are the languages that we now have available. Weaviate is in a language, and soon we will have many more languages. So for example, if you want Greek, then just let us know and we'll add Greek to it, but we need some help with with validating it. We have a specific tool, so compound splitting. If you scroll over it, it actually shows you what that means. The version, the setup mode, and which kind of model you want to use. And you can actually download the Docker Compose setup. So let me just do that in the browser for now. So this is just then it just downloads the Docker Compose, and the only thing that you then have to run is Docker Compose up. You can work with Weaviate. The second option we have are the cloud deployments. So currently we have that on the Google Cloud Marketplace. So if you Google for Google Cloud Marketplace and then you go to the marketplace, explore the marketplace. You type in Weaviate, you can't miss it. Here it is. So now you can select Weaviate, and you can just with one click of a button, you select the project that you want to have it in, configure, and you can also choose the open source version there, and you can start working with Weaviate right away. Then we have the cluster service. Our cluster service is a service which you can log in and create sandboxes. You can create sandboxes also for free for 2 weeks. And then we have the whole Kubernetes setup, which I'm not going to dive into right now. Now, then if we continue on our documentation, we have 2 client libraries currently, Python and JavaScript. I'm going to get back to those in a bit. We have some example data sets. So the example data set that I'm going to demo from is the news publication set. And then we have two types of APIs. So we have the RESTful API. So the RESTful API comes with a schema, the things that you can get and add to Weaviate. You can batch things, do classifications. We have something called the contextionary, which I will explain in a bit, and something which is a meta endpoint to see if Weaviate is running. So Weaviate starts from the perspective of the schema. So Weaviate comes with a class-based schema, and the schema is something that you can get from the V1 schema endpoint. And we have a demo data set online. So let me use that as an example. So this is a Weaviate that this is running, and this runs the news publication data set. So here you see how such a schema, what it looks like. So in JSON, let me make it a little bit bigger. Yeah. So what you see here is you see here we have publication. Publication has a name, headquarters geolocation, and articles related. We have authors. Authors also have a name. They wrote articles. And then we have, of course, the articles themselves. And as you can see, it's graph-like because, for example, if we look at the publication, then we can say, well, a publication has articles, and the data type of an article is article. So if we now go to that references, of course, where are you? Article here. That references the actual class article. This is something that you will also see come back in the GraphQL queries. Everything that you can do, so you can get a schema, you can create classes, delete classes, add properties, and those kind of things, which is all explained in the documentation. So if you just click, if you want to do it in JavaScript, you just click JavaScript, and then you see the examples there. Secondly, we have semantic kinds, and semantic kinds are for us things or actions. So you can also say nouns or verbs. And those data objects are represented like v1/things if you want to see all of them, or you can get specific ones with, let me find it, where are you? Get a data object. So you can also do v1 semantic kind and an ID. So to show that in action, so if I now do things, and you see here the latest added thing. So this is an article. Here you see the authors that the article has. You see in which publication it is, and here you see the summary of the article and the title of the article and the URL. Now, if you would say, now, okay, so what would be, what is this article which is called what we want to see from Microsoft, etc. If we then do things/that idea, we actually can see what it refers to. This comes from the Game Informer. So that's how Weaviate is structured. Now, if you've added Weaviate, if you created a class and if you added data to Weaviate, then we get to the exciting part, because the exciting part is actually getting the data out. And that is where we use GraphQL for. And as I mentioned, if you go to graphql.org, you can learn more about what GraphQL is in general, because it's an existing query language which we adopted. So let's do cat. So here you see an example to get a simple example to get articles out. And what we also have on the website is here you see the green bullet where it says like click here to try it out. I'm going to do that because that's actually what we use to show you how Weaviate works. Okay, so this query says, let me make it a little bit bigger for everybody. Yeah, so this query says like, well, I want to get things, and the thing that I want you to get is an article. I want you to show the title, the URL of the article, and the word count. So if I now run this, then you see, here you see the representations of these articles. Now, if you go back to the examples from the presentation, then we've seen, well, I want to get things, and I want to see publications and show me the name of the publication. So if I now run this, what this query should do is that it show me all the publications that are loaded in this Weaviate instance. So you see the Financial Times, Wired, Vogue, The Economist, New Yorker, International New York Times, blah, 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 etc. Now, what we can do, and that is something which you can find in the documentation under filters, is that we can specify the machine learning filters. So let me give you an example. If I now do explore and search for the concept, and I want you to search for the concept fashion, and I want you to do that with a certainty of, let's say, 0.8, and I run this query, then it should return a publication, the name of a publication which has a relation to fashion. So if I run this query, you see it returns Vogue. But as you see in the data object, we know where we have the word Vogue. So Weaviate understands that there's a relation between fashion and Vogue. So, or if I would say economy, oh, then I should make a typo, economy, and I run that same query, then you see, for example, that it shows the Economist. Or if I do finance, oh, it shows nothing. That's because my certainty is too high. You see finance, you see Financial Times, The Economist, the New York Times Company, etc. What certainty does is, and then I'll quickly go back to my presentation. What certainty does is that this circle that you see here, the higher the certainty, the smaller the circle, because then it needs to be as certain as possible what the query is that you're looking for. So that's why I couldn't find something when I had a lower certainty. So if I now increase the certainty, the amount of results, so I now have 5 results related to finance, but if I increase the certainty, you see it goes down. So it becomes more certain that it says it has a relation with finance. Now, we can also do this for bigger. There's one more thing that I want to show there. And what we can also say, for example, if we want to make a graph, we can say, well, has articles, and then we say on article, we can show the title of that article. So what you see here is how we start to create the graph. So now we go from the notes publication to the property has articles, and then we show the title of the articles. So if I run this query, and this probably takes a little bit longer because it now needs to get in all these articles from these publications. So now you see what the articles are that are relations to these publications. So these explore functions and these concepts are things that we can also do for a bigger text. So let's say we get something again. I'm going to get a thing, but I'm now not going to a publication, but I'm going to an article. And I want to get the title of articles. So let me just run this. So you see all these random articles. So let's do this again. So now let's say, well, I want to explore for the concepts, and I want to find housing prices in Asia. And I'm going to say I want to be pretty certain about this one, and show me the title. So if I now run this query, you see that the prime predictions houses in Asia, and you see that it even also has something about the housing market in Athens. So now, what I can do now is that if I want to be more specific about something, I can say, well, I want to move away from concepts, and then I can say, for example, I can say Greece, and then I can say force. Sorry, everybody, that I'm going to move away from the concept Greece, but it's for my demo. So, and I'm going to move away from the concept Greece. Oh, and I need to lower this a little bit further. What you now see is that let me make it a little bit higher. So what you now see is that these the housing prices in Asia, that it finds the right article, but it also found, of course, the article from Greece because of housing prices. So what I can say, well, I want still find these articles, but I want to move away from the concept of Greece. And if you now look at the summary, so we can just add that we can actually also show what the summary is of that article and why it's related to this. This does not necessarily mean that those keywords are present. It looks in that vector space what everything means. Now, one more thing that I want to show in this console based on that is that, I need to go here. We also have something which we call underscore properties. And underscore properties give more insights based on search results. So for example, if I go here, let's go back to the finance example, because that's a relatively easy example to show this. So this one, and then, so here I'm saying again, okay, show me related to finance. Let me lower that a little bit, that I have a little bit more results. So here we see publications that have relation to finance. So what we now can do is that we can use the underscore properties. So for example, what we can do is that we can say, well, we want to see an interpretation. And the interpretation means, like, how did Weaviate interpret these data objects? So I can see source. So here you see Financial Times. So it says, like, it has like it used the word publication, it used the words financial, it used the word times, and these are the occurrences and the importance that it has in the in indexing. And the same as here, we have a publication with The Economist. So this is the importance of indexing. But what you can also do is that we can say, well, I want to see a semantic path. And what the semantic path does is, and that's actually pretty cool, it shows how it got from the result to the query. So let me show this. So path, here we go. So it's now loading in all these results. So let me get from the start. So it said, okay, I got from Financial Times. I went from via retail, foreign, ASBC, financed, quarterly, finance, to a relation between finance. That's how it went to that vector space. Or if we look at, let's take another one. So here we see The Economist, and you see here it went via PwC, retail, budget, taxes, foreign, HSBC. This is the path it took to actually got to this query and make these relations. And what we also have is, for those who want to visualize the examples, we have something called feature projection. So what you can do is that you can say, well, I want to do feature projection vector, and if I run this, then you see here it gets coordinates. Every result gets, so the Financial Times get a coordinate, The Economist gets a coordinate, and what you can now do with it is that you can visualize your results. Quickly looking at where I stand with time. Yeah. So what I want to do is that I also want to quickly show you something before I'll wrap up about the libraries. So we have these Python and JavaScript libraries that you can use. So if you don't want to directly use the API, so let me. Oh. Let me quickly open this. So what I can do is, if I install Weaviate, so if I go Python, of course, I need to do the installation, so I need to run pip install Weaviate client, but I've done that already. So I can just do import Weaviate. And then one of the things that I can say, well, I need to create a Weaviate client. So what I can do is Weaviate.client. And then I need to send it to my URL where Weaviate is coming in from. And for my demo, I'm going to use the demo data set, which you can, by the way, also try out yourself. Playground. So now I've loaded in the client, and now I can, for example, get the schema. So I can say, well, client.schema.get, and then I can say print schema. Or actually, let me do that like this. Let me do that JSON schema. It's better. If you want to look up this query, so how do I know that I need to use this? Well, so if I go here to schema, and I said, like, get the schema, then I can just, here in Python, you can see where it's coming from. So now I can save this, and then if I run Python then, oh, of course, I need to import JSON. Otherwise, it's not working. Let me try that again. Here you see the results actually is coming back. So this result, what you see here represented in JSON, is exactly the same as you would see here at the schema endpoint, but now you can access it through JSON. So what we can also, for example, do is that we can do an explore search, as I just demoed, is also something we can do. So let's do that. So let's say I have an explore function, which is, I have the concepts of, well, let's take the fashion example, fashion, and then I can say, set my certainty, I set it to 0.8, and then I can do result is client.query.get.things, and then I can say, well, I want you to find the publication. And what I want to see is the name of the publication. And then I want you to add the explore function. So I can do with explore. And then I add explore. And then I say do. So this is like, so I say the client, I want to do a query. I want to get things, give me the publication and show me the property name. The reason this is an array is, of course, you can have multiple properties. I want to add an explore function, which is this one, explore, and then I want to execute it. So then I can say print JSON dumps result, and then indent is 2. So if I now, let me run this query, and then I make a mistake, I forgot a comma. Live demo. Yes, so here you see that same result. So here you see the publication with focus coming back. And that is something that we also seen here in that example that I showed you. Where is it? And so this is the same. This GraphQL query is represented like this in Python. Well, etc., etc. So that's how you can play around with it. Let's go back. So you can find more about Weaviate on our website, semi.technology. That also will lead you to our GitHub page. And if you're on a GitHub page, then please don't forget to give us a GitHub star. And this is my contact information. So if you have any questions or you want to reach out or you want to build something cool, then let us know. Oh, and I forgot to add something very important to this page that is on our website. So if you go to just semi.technology, you can click here to give us a star on GitHub, but you can also join our Slack channel. So if you are on our Slack channel, then we can connect and you can also see what other people are building. So we hope to see you there. Thank you very much. And it was great talking to you. And I hope you got some inspiration and insights from working with Weaviate. Thank you.
Thank you, Bob.
You're very welcome.
Unfortunately, we don't have time for questions here. And please visit our Slack channel, where Panagiotis has already said the questions that people have for Bob. And Bob will be there to network with you and tell everything you want to know. Thank you, Bob, for coming.
Thank you. I will be on the Slack channel. Bye-bye.
And our next speaker is Katerina. Let me share my screen a little bit. And yes, here she is. Katerina is a Google developer expert on Angular, Google Cloud Platform, and web technologies. So she has a lot to share with us. Give me one moment so that she will be able to talk. Okay. Katerina, the floor is yours now.
Hello. Okay. I'm not sure I can share my screen. Yes, I cannot share my screen, unfortunately. The button to share the screen is disabled, so I don't know what to do. Yes, so unfortunately I'm still trying to figure out the screen. I'm really sorry about that. Let me see what I can do. I'm pretty sure I've given Chrome the permissions because I've shared my screen in Chrome before. Oh, okay, yeah. Okay, you can see my screen now, right? I guess, yes. Okay. So sorry about this bumpy start. Welcome. Today I'm going to talk to you about the NX. I'm Katerina Skroumpelou. I'm a software engineer at Narwhal Technologies, the people who made Nx. I'm also the Angular Athens Meetup co-founder, and I'm also a Google developer expert for Angular, web technologies, the Google Maps platform. I'm also in the program committee of Box Days Greece, and I'm also a speaker and instructor and mentor and a cat person. And I also climb mountains. This is from the top of Mount Olympus. And let me check if everything is going well. Yeah, I hope everything is going well and you can hear me and you can see me. It's pretty difficult with these online events sometimes because you don't have any immediate feedback. And I'm going to set my clock now. Okay, so let's begin. Today we'll talk about Nx. We'll talk about what is a monorepo, what is Nx, is Nx only for monorepos? Spoiler alert, it's not. Why use Nx? And we'll see the features that Nx offers, and we'll see a little demo, as always. So, what is a monorepo? So, in one sentence, a monorepo is a single Git repository which contains all your applications. Terrifying, right? Well, some facts about the monorepo and some of the misconceptions. It's not a monolith. So it's actually quite the contrary because monorepos actually simplify code sharing and cross-project refactorings, and they significantly lower the cost of creating libraries, microservices, and micro frontends. So adopting a monorepo often actually enables more deployment flexibility as opposed to a monolith project. However, it does mean that there are multiple projects in the same repository. And this is good because you can manage your dependencies. Projects can depend on each other so they can share code. For example, think that you have a front application and a backend application in the same repository that share a common UI component. You can do that with Nx in the monorepo. And also, it does not mean, another common misconception is that somebody may think that if you change something, then you would have to rebuild and retest everything. This is not the case. Instead, you only rebuild or retest the affected code. It also gives you independence because if you have a large team, you can actually split them up and only give them parts of the monorepo to work on a single component in a single library or a single project. So it gives you a lot of independence. And also it provides you with consistency and predictability. And we'll talk about that. So what is Nx? Nx is a set of powerful, extensible dev tools which help you scale your app and coordinate better with your team, which is good. It's a tool that can dramatically simplify the way you organize, test, and share code between multiple JavaScript applications. The tool itself is based on the best practices developed in Google to scale thousands of applications across thousands of developers in a single monorepo. But, of course, you don't need to be operating at Google scale to see the benefits of Nx. It can be a very powerful tool for projects of all sizes, and not just Angular, because Nx is very much connected to Angular in a lot of people's minds. It's not just for Angular, but for full-stack JavaScript in general, and we'll see that in action. So why do big companies like Google, Microsoft, or Facebook like to manage their codes in monorepos, or in other words, use a single Git repository, as we said, to manage multiple applications and libraries? The simple answer is that this approach helps manage complexity by applying best practices organization-wide. This delivers consistency and predictability, as we said, in the code, by also maximizing the ability to share the code between projects. So Nx, however good it is, it's not only for monorepos. So, no. Why, though? First of all, it gives you out-of-the-box configuration of frameworks and modern tools so that you can focus more on your application and less on configuring it. You can easily share your code across multiple applications or teams while enforcing clean integration points, as we will see. And you can use the dependency graph, which we'll see in a bit, if your code in your code base, so that you can run tests or other actions on exactly the areas affected by a PR and nothing else, because Nx analyzes your code and actually finds all the dependencies and creates a graph and understands when something has been affected. Other reasons are one of the main reasons to use Nx, regardless of where you have a monorepo or not, or whether you're a large team or not, is the CLI. It's the tooling that it offers. It's the schematics that Nx offers. It's the workflow management, the dependency management, and the Nx Cloud. And let's see these things one by one. So first of all, the CLI. The Nx CLI will help you generate apps, test them, run them, and organize them. You can have commands like the ones I've listed here. You can create an Nx Workspace, which we will see how it will look in the demo. You can generate a new Angular application. You can generate a Nest backend application. You can even generate a React application. You can generate components. You can generate tests, end-to-end tests, and you can build and test your affected code. So it's very powerful. Let's see some of so as you can see here, this is the Nx site. You can see, and I will give you the link, you can see everything that the Nx CLI offers. It gives you the generate command, as we said, the serve command, the build command, and the test command, but it also gives you the lint commands, where you can lint a project, the E2 commands, and the run commands to run your tests, the dependency graph, which we will see, which is the one that excites me the most. You can use the run many commands, the affected commands, and we'll see all the rest. So it's very powerful. Also, it's the tooling that I talked to you about. We saw the dependency graph, and we'll see it in the demo, the affected, but it also provides you with a migrate command, which will take care of automatically generating some migrations in your projects and your files. And it will create a migrations.json file, and then you can run the Nx migrate command to take all the commands from this file and actually migrate your code automatically. It gives you the report command, which will just tell you everything that you're using in all the versions. And you can also use other types you can format your code, and you can also have the report. You can also move things around, because when you create an Nx Workspace, it has some things where it wants it to have, and when you generate a library or a new application, it will be in a specific place. You can move it around, and Nx will take care of updating all the imports. You can use the run many command, which will it will allow you to run tasks for multiple projects simultaneously. So for example, you can test everything, or you can use it for other types of things. Also, it gives you the plugin for the VS Code, the Nx console, which is a graphical user interface where you can use all the powers of the Nx CLI in the VS Code by clicking buttons and adjusting dials, which is very, very useful because you have all the commands that are available for you right there in front of you, and you don't have to remember commands by heart and copy and paste them anywhere. Also, it has a lot of plugins. So let's see some of the plugins that Nx has. First of all, it has, for example, plugins for Angular. And Angular offers a number of schematics. Schematics is when you run a command and it generates a bit of code. So you can generate an Angular application, you can downgrade something, you can have karma, you can generate a library, you can move things around, you can add NGRX, and it will generate some basic NGRX boilerplate code in your application. And another thing, of course, for React, again, you have schematics. You can generate a React application, or you can generate a React component or a React library. You can add Redux. Again, for Jest and Cypress, you have some builders. But for nodes, again, you have schematics. You can generate a backend node application or a library. For Express, the same, and for Next and for Nest. But also, you also have Storybook, which is a very very powerful tool to test your front-end components. And actually, Nx will use Storybook to generate stories for your application, which we'll see in the demo as well. So you have a lot of plugins and a lot of schematics, which will help you minimize the boilerplate code that you have to write, and it will scaffold everything for you. And we'll see it in the demo, I promise. So we talked about schematics. There's a schematic, as you saw, for anything you want to generate. You can create also your own schematics. You can generate a React application, as we said, a node library. And you can also create your own schematics and use Nx to run them. Nx also helps you add all the tools you need and use them from within Nx. You can organize your tests, your builds, and your CIs. Also, you have the dependency management, both internally and to external resources. First of all, you have the dependency graph, which we will see in action, which is very awesome. It shows you all the dependencies within the project, from library to component to application. It also helps with releases and versions because you only have one package.json file, and this single package.json file has the single versions of the applications you're using in all the libraries you're using. So it's very convenient. So for example, if you're going to upgrade React, you will know that you're now at React 16, and this is true for all your projects. So you don't have like a headache trying to figure out which version of React I have here and which version of React I have there, for example. So it's very, very useful that you only depend on one package.json file. Then you get access to the Nx Cloud. You can expand Nx's local computation memoization, which is the caching essentially, to the cloud. So you have Nx cache locally. So if you run a command to build or to test something, and the Nx cache will take up, and it will know that if you rerun the same command and you haven't changed any code, it will fetch the results from the cache. If your team member has already built or tested similar code, Nx will use the results to speed up the command instead of rebuilding or retesting everything from scratch. And you can do that with Nx Cloud, which will be a lot faster. And when you're generating an Nx Workspace, you can opt in or opt out of Nx Cloud, but it's very, very useful because it speeds up everything. So let's spend the next 6 to 7 minutes, actually next 5 minutes, looking at the demo. First of all, I'll show you, no, actually, first of all, let's try to create an Nx Workspace from scratch to see what Nx will let us try. So now, in my local machine, I will just write npx create Nx Workspace demo project. Now Nx will start running. It's using npx, so all you need to have to run this, sorry, let me make this bigger. I think it's good now. So all you need to do for this to run, you need to have the latest npm and npx installed. So you want to create a new workspace, and you can create an empty workspace, but you can also choose any of these options you want. I will choose right now to create a React workspace. The application name will be my demo app. And I want my styles, as you can see, there's a lot of options, to be Sass. And do I want to use Nx Cloud for faster builds? Of course I do. So it will create a sandbox with Nx now. So here it will show you all the options you made. And it will take some time, not very much time, I promise, but it will create a workspace, which we will see here. So it has all, let me make this even bigger. So my demo project here, which is almost generated, has a workspace JSON, which will be, a lot of things will be added here. But if you have used the Angular CLI, you will know that this is the equivalent of Angular JSON. So as you can see here, as the app generates, which is also generated at most, it has this architect. So it adds each application here. So for each application, you have your demo application, and you have already the E2E tests generated. So you have the demo application, and then you have the architect, which you tell it some commands, how to build it, and which Nx package to use so that it can build. You have some configurations. You have the serve, the lint, the test. And again, you have the same for the demo E2E applications. And then you have the schematics that we have installed. I have only installed the React schematics. And then you have your package.json, which lists the available commands here in scripts, which all can run by running nx start, nx build, nx test, etc. And then you have the dependencies. So and then you have the libraries folder, which is now empty. If I wanted to generate a new React library, I would go and write nxg narwhal React library, and usually a library is a UI library, so I would do it like this. And this would generate a library for me. So under the libs folder, I would have a new React library. You see everything is generated here with a new React component, right? And if I wanted, I could add Storybook as a new plugin. So I could add this as a dev dependency, the package narwhal storybook, for example, and it would take some time, and eventually it would appear both in package.json and in my plugins down here. As you can see, the workspace JSON has also been updated with my UI library that I just created. So this whole demo project, which let's also try to, so yes, let me refresh. And so now you see here that we also have the narwhal storybook. So let's try and run it. And this will start. So let's try this one here. So another example here in the demo project, you can go to github.com and you can go to Norwell Nx examples, and it will give you a fully working Nx application, which let's see what it has. So this demo project we just generated now from scratch. But these Nx examples is a full-scale application, which has two applications. One application that is React and one application that is Angular. And it also has some libraries. And what is very interesting in the libraries, you can see that there is a shared library and a header component in the shared library, which this shared component is both imported in the Angular library like this. So because it's an export library, you can import it as a module. So this Nx example /shared /header points to this header here. And it is both imported in the Angular component like this, but it's also imported in the React application like this in the same way, which is amazing, right? The other amazing thing, in my opinion, that you have is that you can have your, where is the state? You can have your state. So you can have your NGRX actions, reducers, effects, or whatever you have. You can have your NGRX configuration as a library. So this is pretty amazing as well, because you can use it and import it like this everywhere in your application. So some commands that you can run is, first of all, is the dependency graph I told you about. So let's run the dependency graph for this application. You can run it by Nx dependency graph, and let's display all the projects. So as you can see, for example, the shared header is used by both the products and the cart application, and it uses all these other components that we have. So on top of everything is the E2E tests, of course, that depend on the two applications. And then you have the two applications that depend, for example, on the shared header, which depends on this, and the products, which depends on shared assets as well as the cards. So by running this command, you can actually see how everything depends to everything. And you can just decide to show some of the things, which is pretty cool as well, in my opinion. So this is the amazing power of Nx Graph. Let's see if we have something else. You can also run, you can also serve the application by using Nx Serve products. And let's wait for it to compile. And again, this is the output of the Angular application, for example, and it will be in localhost. And it will be like this. And in the same way, you can add the cart. And again, it will do the cart thing. It will, serve the cart application. So both applications, as you can see, have the same header. The cart doesn't have anything inside. The products has the list of products, but both have the same header components. Let's see if I saved any other command to show you. Oh, and you can run the end-to-end test, for example, by running nx e2e cart e2. And this will just run the end-to-end tests. So let's wait for it. Yes, it ran the tests. and everything is correct. So if I do also yarn nx build, it will build both applications, and if I run it again afterwards, it will use the cached build. So where is my presentation? I showed you both of this. Let's see actually if it built it. No, it didn't build. If it has built it until the end of my talk, you will see that if I run yarn nx build again, it will just build the cache thing. So what I would suggest is that you find us on GitHub. On GitHub, there are a lot of examples, and there's also a huge community of people that support Nx. And you can file your issues and you can ask your questions. And among other people, I will also be there to answer your questions. So some of the links we talked about today, it's the Nx dev, which is the main webpage for Nx. It's the Narwhal Nx page on GitHub. Here is a post about monorepos, and here is a post that talks about the affected flag of Nx, which is very, very useful, where you never build the same code twice. Then is the Nx Hub, which is the Nx Cloud web page. And then there's a post about the Dependency Graph and some new features of Nx, which are very, very useful. Before I finish, let's see if it finished building. Okay, so now if I run Nx build again, it shows the cached output, and it didn't build the same code twice. It just used the cache. So after I showed you the power of Nx, I will say thanks. And you can find me on Twitter at CyberCity or at cyber.city is my webpage, where I have all my links in there. The Nx dev is the site of Narwhal, and these are my slides that you can go to this link here, bit.ly/devfest-cat-nx, and you can find all the links and all the things we talked about today. I will leave this slide to sink in for a few moments. You can take your screenshots. Okay, so that was my presentation.
Okay, thank you, Katerina, for coming. Unfortunately, we have only 1 minute or less, so please join the Slack room, and the people will find you there and ask you anything that they want to know. Thank you for coming. It was an honor to have you here.
Thank you very much for inviting me. It was an honor for me to be here with you.
And now we are following up with our game. So let's go here. Game. You have to go to kahoot.it. Michalis is going to give you a pin. You will enter it and you'll start playing the game. Please give me some moments. Michalis, the stage is yours for the game.
Hello, can you hear me now? Hello? Am I here now? Okay. Let's waste more of your time. Okay. So, does everybody see the screen now? Not yet, I think. Right. Can anybody confirm if I am here or see now? Okay. Okay. How about the screen, Maria? Thank you for confirming. We started having two, right? Okay, get it. Remember to use another device so you can also see the questions on the main screen, and use your phone, let's say, for logging in here and answering the question. Because on the device you use to join the game, you will not be able to see the question, only the buttons to answer the questions. And remember, after the game ends, if you are one of the winners, please save a screenshot of the winning screen and email it to us so we can reply with your gift. Okay, let's wait a couple of minutes for people to join. Hello, Fatima, I think I'm back. Unfortunately, we lost the connection on the video and the screen share. I think I can see that some players are still playing, probably answering random. Is it back now? We still have 4 questions to go. Let's see. Okay, let's see. Okay. Cool. Okay. Okay. Next question. Some people are complaining that they are not seeing the question, but I can see that people are maybe random. Let's see. I just tested from the YouTube stream and the screen shows there. Okay. Next question. Last question, guys. Okay, that was the last question. It's first, Efthimios second, and first winner is VSA. All right. Great. Remember to print screen and share with us the screen that shows your name and your position for the win, and we can respond with your gifts.
Okay, people, thank you, Michalis. I know that we had a problem, but we're going to solve it for sure for the next games. Now, let's see the correct answers. Please don't forget that you have to take a from your mobile phone and send it to us. These are the answers of our first game. We're going to our next speaker, who is Panagiotis Tzamtzis from Perksquare. Usually we ask the questions at the end of the presentation. I have already asked Panagiotis my question, and his daughter is awake and she will hear him. So give me one moment so that Panagiotis will be able. Okay, Panagiotis, the speech.
Hello, I guess that everyone can hear me now. Let me try to share my screen. Okay. So today I'm going to walk you through a project that we have developed in Perksquare. And I will try to walk you through the whole process of imagining the project, the reasons why we created, what are the tools that we used on Google Cloud to create it, and what are the lessons we learned through the whole process. Let me first walk you through and say a few things about the team of Perksquare, so that you can better understand what was the whole reasoning behind this project. So, in Perksquare, we are a team that we aim to make data worthwhile by focusing on action-driven analytics. So this means that we usually focus on products and services that aim at data analytics. We handle data collection and data analysis. And we also try to make lives of analysts easier by automating actions, detecting which actions need to be automated, and designing smart workflows that will make everyday life easier. We are a team that spans across 3 countries. We have about 30 people today in our team. The main base of operations is Greece, Thessaloniki, where all the analysts and data engineers and software developers are. But we also have a presence in UK with marketing and technical support services, and presence in the US for sales. Today's project will not cover all of the products and services we are focusing on, but it will mostly focus on data analysis. It's a project that aims to collect data and help analysts analyze the data and get the useful insights that they can then present to the clients. So let me dive inside the project details and explain to you what was the goal. Our team is usually responsible for web analytics and SEO and the general healthcare of the website. So we had to create a tool that would allow us to analyze a website in as quick as possible and with efficient use of resources. So the goals of this project were to crawl large websites automatically. And when we say large websites, we mean websites that consist of more than 100,000 pages. We also wanted to find a solution that would scale easily. We didn't want to build something that can only be used by a single client, but we want to have a solution that can scale across multiple clients and to be able to extend that across multiple more pages if needed. And also to have a solution that can scale in functionality. And the third point is that we might not be 100% software company, but we need to build professional solutions because the clients we are working with are enterprise level clients. So we had to have continuous integration and continuous development and allow cooperation across multiple team members, which may not even work at the same office. The fourth point is about secure and scalable data storage. Today, most of us know that data storage is quite cheap, but in a professional environment, it's not that cheap to have secure data storage, which is very important for companies. The fifth point is fast and easy data analysis. Most of us here on DevFest are developers. We love to write source code and to use new tools, but with data analysts, this is usually not the case. A lot of people that are great in crunching numbers and getting insights from a lot of data are not very techie or geeky like us. So we need to also find a way to allow people to go through the collected data easily and also in a fast way, because when we talk about big data, it's easy to have very slow speeds. And the last point was short development time. When you create something for clients, you want to have quick results easy and in a short amount of time to allow you to be competitive in the global market. This is also why we use the cloud for this project. Let me also walk you through the difficulties of the project. So, as we said before, we want to have a project that is scalable and can work on large websites. If you try to Google site Samsung.com, you will see that it's a website that consists of 4 million unique pages. So imagine having the responsibility to crawl the complete website across the whole world every day or every week. This is a task that cannot be completed within the office of a team that consists of 30 people, but using the cloud, you get the resources necessary to complete such projects. We had to have frequent audits and historical data. So this requires a lot of storage, fast storage, and a lot of computing power, because when you have to crawl 100,000 pages or 1 million pages, it's not something that you can do on a single PC. And you also need to have accessible logs to keep track of changes and compare them against when running tests. So you need to have easy access to all of the data. The third difficulty was that the ecosystem of the web and is very complicated. When you work with SEO, page performance, web analytics, accessibility, and content, and you are responsible for all of these aspects of the website, it's you need a very large team of experts, which is expensive and also difficult to find. So in a team like ours in Perksquare had to find a way to dumb down this problem in a way. Because it's also very easy to have issues which can go unnoticed when you consider the complexity and the scale of large organizations. In addition to that, the standards on the web change very often. You know that the best practices for SEO, for instance, are not the same as the ones that used to be 6 months ago. Even page performance and web analytics and accessibility have different standards every year. So it's not something that is easy to keep track of. And we wanted to find a way to automate this and reduce the necessary amount of people that need to go through and manually test websites. Fixing also an issue can be a complicated process because with enterprise level websites, you cannot just call a single person and tell him, oh, hello, Panagiotis, I'm having a problem with this and that, and ask him to fix it. You have to go through complicated processes and spend a lot of time in communication, which can slow down issue resolution. And lastly, on the web, it does matter what your competitors are doing. So ideally, we wanted also to find a solution that would not only allow us to check the websites of our clients, but we also want to be able to check the clients of competitors. Because when someone searches on the web for a hotel in London, you want your site to appear first in the list of the results. And this can only happen if it performs better than the competition. So we have a difficult problem with a very big scale that it would require a lot of manpower to complete. So the solution we found and the objective that we had in mind was that we had to find a smart way to automate the approach and scale down this problem into a data analytics use case. Because at the end of the day, our team loves data, and we want to collect the data and just give them to data analysts to find the solutions and pinpoint the problems. Let's get a little bit more technical and go through the parts of the solution. So the first thing that we needed was infrastructure. All the source code that we created had to run somewhere, and what we selected was Google Cloud. It offers us scalable infrastructure. It makes the security on an enterprise level environment and the DevOps operations much easier, and offers a lot of compatible tools that can speed up the delivery of the project. It also offers a lot of compatibility between the tools. You don't have to worry if this tool can work easily with the other. And it can ensure that you have consistent availability of your application, which is also very important, especially if you want to scale this into multiple clients. The second thing that we needed is a testing framework, because what we are trying to build here is a testing application that tests SEO, web analytics, accessibility, page performance, and everything that can be important for the healthcare of a website. For this task, we selected Google Lighthouse. It's a complete framework that is actively supported by Google in case anyone is not aware of it. It already offers a library of automated tests that covers accessibility and SEO use cases. It's very easy to learn, so it's something that you can easily start using. It's also future-proof because it is actively supported by Google, and to tell you the truth, the biggest issue here is to keep up with the updates that are getting posted and understand how they impact the data quality exactly. And it also offers a lot of rich insights, even suggested resolutions for your issues. And lastly, since we are talking about a project that crawls through websites, we also need a web browser, but we don't need the web browser that we are using as users. We need a browser API. We need to emulate different browsers and screens. And we also need to make sure that the browser that we are using is not just an emulator. We want to have the same outcome inside the browser that we would have as normal users. So the best solution out there today that we found was Puppeteer. This is a browser API that allows you to automate surfing on the web. You can just write code and navigate through web pages and websites and automate different actions. It also ensures that you have the same you have the website behaving exactly the same way as it would on a normal browser. And it also starts supporting different browsers. It has partial support today for Firefox, and there are, or in the roadmap, there's also better support for Safari and also better support for Firefox. So it's a very future-proof solution as well. Next, I will walk you through the solution diagram now that we have a good understanding of the technologies that we have used. Here, we will go through the Google Cloud tools that we used and how each tool was used and what was the logic behind it. So the first tool that we used was Cloud Scheduler. This is like a beautiful cron job, let's say. It offers a UI and it can allow you to just spin up and start processes by writing simple cron jobs inside the UI. So we set up a cloud scheduler, one for each client that spins up a virtual machine. This virtual machine is hosted on Compute Engine, and the way to spin up a virtual machine through Cloud Scheduler is by writing a very simple cloud function that will create the virtual machine with the specifications that you want it to. As soon as the virtual machine is created, as first task, of course, would be to install the necessary libraries and dependencies. This would be a simple bash script that you will write once and that you can also have hosted on GitHub and can be downloaded automatically from GitHub when creating the machine. And as soon as you start installing the libraries, the first task we need to complete is to find the URLs that we need to crawl. So when we talk about such large websites, we have two options to do that. Either to get a list of all the URLs and feed it to the application, or to find a more automated way to do that. The solution we chose was to do the more automated way. And the way we did that was by crawling the sitemap.xml file that is usually available on all websites that have a decent SEO quality. This file includes all the URLs that you need, that the site includes. So what you can do is to crawl, just define the domain names that you want to crawl, and let a simple Python script, in our case, create a dictionary of all the URLs that need to be crawled. As soon as this complete dictionary is completed, you can also choose to exclude maybe some of the URLs that might not make sense for the test that you are planning, and have the final set of URLs that need to be crawled. No, so now imagine that we have a data file that contains all the URLs. We can store this very easily on data storage. It's a file system that allows you to store files and easily retrieve it from anywhere inside Google Cloud or outside the cloud, if this is the use case. And the next step is that we need to start to understand what to do with these URLs. The option we selected was to start publishing all these URLs to PubSub. PubSub is a great tool inside Google Cloud that allows you to create a queue, a serverless queue that lives inside the cloud. So we push all these URLs to PubSub and have a queue that that can start getting crawled by test machines to go through the URLs. And the last point here is to start these test machines. As we call them workers, because in the virtual machine that crawled all the URLs, we named it master. So we had the master that found the URLs that need to be part of the testing process. And as soon as it created a list that can be publicly accessible from the workers, it starts all the workers. And finally, turns off the master machine that is not in use, that doesn't have any, we don't have any use for it anymore. So when the job of the workers is to go through all of the URLs, as we said before, we need concurrency here. And so we start a lot of workers. We try to automatically estimate the number of workers which are needed to have the tests ready in a specific amount of time. And since this lives inside the cloud, this can scale from 1 or 2 workers to hundreds of them. So the workers get all the URLs from the PubSub queue. Each worker gets a single URL and start going through each URL. So imagine that you are crawling a lot of URLs at the same time, and each worker stores the data that are needed in BigQuery in a database format, and also stores the flat files of data in Google Cloud Storage just as a backup, and in case you need more detail than the ones that you have in BigQuery. As soon as the PubSub queue is empty and all of the URLs have been crawled, we can just go on and turn off all the VMs and that were used as workers and complete the whole process. And here you see that now that we have all the data that we need in BigQuery, and we can just go and crawl through the data. This includes data that we have collected from the default tests that live inside Lighthouse. So SEO tests, accessibility tests, and also data that are included that have been extracted by tests that were written by our team. So we can go and test the web analytics infrastructure. We can go and test the content based on the business requirements and anything else you can think of. The final step would be to report on the results. Here we have the option to use Lighthouse reports, which look really nice and can be shared also with clients in case it's necessary. These reports are page specific, and so it's very granular, and it would not be easy to use that for the whole website. We can also create Data Studio dashboards. It may sound as the poor man's analytics, but it works very well with BigQuery, and you can even get real-time reports. So as you can see here, we can even understand how the whole testing process looks like in real time. And finally, we can also have Perksquare's software, which is doing automated analysis, go through the data inside BigQuery, or use machine learning, or even traditional statistics to go through the data and detect useful insights. Wrapping up, I would just like to let you know about a few lessons that we learned in the process when using cloud for this project. So we found out that the serverless approach and the serverless products that are offered by the cloud are great, like Cloud Functions, but even the more traditional virtual machines in compute engine are great for parallelizing long-running tasks and in pretty low cost. There is a requirement for more maintenance, but it's much easier to use it down the line. The one thing called instance metadata is very important in the cloud to keep track of the execution. For us, for instance, we just by keeping the host name of the virtual machine inside the BigQuery database allowed us to have a real-time dashboard showing how the whole testing process is working. For BigQuery database is pay a lot of attention to partitioning. Is the most important thing to reduce the cost when running queries and storing data. By partitioning your tables, you can minimize the cost of your queries and also make the storage costs much less. Data Studio and BigQuery, there's a lot of love between one another, even in real time. Trust me, by joining the two, it will be very easy to do a few tests on your data and understand the status and run a quick analysis. Try using cloud tools as much as possible because they are created to work well with one another, and you don't need to reinvent the wheel every time you need to solve a use case. Keep in mind that there are a few artificial limits in cloud tools, but don't perceive them as blockers. When I started working with Google Cloud, I had in mind that I could scale up to, there was no limit in scaling, and very quickly I found out that there is indeed limit in scaling. To overcome this limit, you just need to raise request with Google Cloud and ask them to raise the limits. This is a very quick process, and these artificial limits are only there to protect you in case of you do something that you don't understand what would be the cost implications of it. A Lighthouse is more than a predefined set of SEO and performance audits. As I mentioned earlier, it's a complete scalable testing framework that you can use to extend and automate other tests as well. And it's also important, lastly, to study all the details of each cloud tool, because even the smallest details can make a big difference at the final product. Maybe just as a quick example, I can say that with PubSub, there is an important detail that every item in the queue will be delivered at least once to every worker. So this is something that you need to keep in mind when designing the worker architecture, and make sure that every worker virtual machine will not crawl through the same URL every time. And finally, I would also like to introduce you to the rest of the team that worked on this project, at least the main actors of this project. because this is not a one-man project. It was myself who worked on the prototype and the data architecture, Lukas Zamboulis, who worked on the product development and the cloud architecture, and Michael Samaras, who worked on the product integrations and analyzing the business requirements and making sure that the test results were aligned to the business requirements. That's it for today. Thank you very much for your attention.
Thank you, Panagiotis, for coming at our DevFest. It was really a pleasure to have you here today and speak to us. It was really insightful. Unfortunately, we don't have time for questions here. Please join the Slack channel, and the people are already there and are waiting for you. Have a great day.
Great. Thank you. Have a great day
Bye.
too. Bye-bye.
So, our next speaker is still a university student who went with the program, Google's program, Summer of Code, to CERN. So, he's ready. Let me give me a moment. And Vasilis, the stage is yours.
Hello, can you hear me? Is everything working correctly? I'm guessing yes. Let me start. So, my name is Vasilis. I'm a student in Patras, Greece. Let me just double check because it has a small 30-second. Okay, great. So, my name is Vasilis. I'm a student in Patras, Greece. I worked over the summer with the Russia team at CERN, along with my mentors, Thomas, Mario, and Martin. Let me just start my timer to make sure we don't go overboard, who were amazing, all of my mentors, so I just had to mention them. My project had the goal of creating a question answering system prototype to support Russia users with any domain-specific requests that they may have. Don't worry if you don't know what Russia, GSOC, or anything I just said is. This talk is quite ambitious. I'm going to try and touch on all of these subjects. The idea was that there are probably a high percentage of students listening, so the first 5 minutes are going to be dedicated to them. Just to give a very, very high-level overview of what Google Summer of Code is. You can, of course, ask me anything after my talk on Slack. So, after that, I will showcase how we implemented the question answering system over the period of 3 months in the summer. But if you abstract out all of the specific implementation details for my team, the pipeline and the whole idea works for any use case you might also need. So let's move on. Enough introduction. So what is Google Summer of Code? It's basically an online opportunity for university students to work on open source projects over the summer. It simply aims at promoting open source software development and introducing students to the cool communities. It's funded and organized by Google, but that does not mean that you are directly employed by Google. You'll simply be working with the organizations and mentors that you have applied and been accepted at. So the way it works is basically mentor organizations choose the students they'd like to accept, and then they work over the 12-week summer break on the project that they have proposed. The truth is that the whole process starts a lot earlier than that. Around February is when the different projects are announced, and you as a student can go through them, select up to 3 of them to create a proposal for. Then around March is when you have the opportunity to actually make the proposal, and in April, you're going to learn if you have been accepted. There is around the month between April and the start of the coding period, which is called the community bonding period. Basically, you get to talk with your mentors, interact with the new community you're now part of, and get to know the project, fine-tune the timeline, and all of that stuff. To give you a sense of the statistics, I think this year 1,200 students, basically projects, have been accepted. So it's quite a large amount, and there were around 8,000 applications total. So if you have a good proposal, you have a good chance of joining this program and working on something cool over the summer. My proposal was for the project called Support for Russo Users with Natural Language Processing, and it happened to be at CERN. So I can definitely talk a lot more about GSOC, but as to not alienate the non-students here, I'll leave you with some links to look around more. I'm going to take a couple of seconds if you want to screenshot this. Also, I'll just upload the presentation on Slack after I've finished. So if you want to take a look at the links, you can find them there. By the way, you can be an undergrad or a graduate student and still apply to GSOC. So for any PhDs here, all of this information also applies to you. So moving on, there are definitely one too many logos here, but the main thing I want to point out is all the different projects and organizations you can choose to contribute to under CERN HSF. I've only managed to fit less than half of them. These are all organizations under the CERN HSF umbrella. HSF stands for High Energy Physics Software Foundation. It's basically a cluster of university laboratories, research centers around the world, and CERN, of course, all focused on high energy physics and particle physics research. My team was Rusio, which is the little donkey logo in the middle. It's also where the name DonkeyBot comes from, how we named my project. All of these organizations that I saw here had projects this summer that you could work on. So they're not just randomly thrown here. And yeah, you can probably recognize a couple of them. Rusio, my team, in a nutshell, it provides mature and modular scientific data management federation. What I mean by that is that it's basically the distributed data management system that CERN uses for all the scientific data from their experiments. Not just CERN, both the other departments that I mentioned before, the HSF community. It started off with the goal to handle just the data coming out of the ATLAS experiment, which is the experiment that detected the Higgs boson back in 2012. But since then, it has matured, and now Rusio, over the years, provides many features to anyone that needs scientific data storage. Just to give you a couple of figures, it can handle any potential payload. It's entirely scalable. It has over 1 billion files right now, over 500 petabytes of data. I think one statistic was it handles like 2.5 exabytes of downloads and uploads per year currently. Not handles, it can handle any payload, but yeah. It has over 120 different data centers connected. And what's more important, at least for my project, is that it has over 1,000 users who use the software and need constant support. So yeah, it's open source, of course. You can contribute to Rusio, and it uses all of the established open source tool chains. So my project, the actual project, DonkeyBot, the concept for the thousands of users that I mentioned before is that Rusio developers get a lot of support requests through emails, and we wanted a way to assist the team in answering these requests. Now, DonkeyBot is the solution, and what we basically want in the final form of the bot to be, even beyond the scope of this summer's GSOC, is to have some sort of an interface or an automated email answering tool for Rusio users that, based on past data, including questions that have already been asked and answered in the emails or on GitHub issues or on the Slack channel, the bot should be able to provide new answers to any simple queries that the user might have. Of course, this will benefit the developers a lot, since less time will be spent replying on previously answered questions. It will also benefit the Rusio user who, when searching for what something means or facing a simple problem, she can have DonkeyBot be the first point of contact in his search, instead of just manually going through all of the documentation and GitHub issues or asking an expert directly. Of course, you can understand how this can be useful in any sort of product. You can basically feed and create a question answering pipeline through your project's documentation, through other data sources that you may have. And basically users, instead of asking you directly, can ask the bot if it has a good enough accuracy, and that can answer their request. So as far as the deliverables we had over the summer, and basically where DonkeyBot is right now, it's basically able to fetch, parse, and use as a knowledge base all of the, not all of them, a subset of the support emails, any GitHub issues that are under our project, and the Rusho documentation. It's also able to detect and archive past questions asked within these data sources, be it either from support emails or GitHub issues. And it currently has a prototype question answering pipeline where we can ask it a question and it gives us back an answer. Now, a little bit about the timeline. Basically, what you'll also have to do to break it down into, let's say, 3 months, ideally. It's important to note whenever you're working on a project like this, you need to spend time and effort in anonymizing and keeping user information secure. So we automatically detected and hashed user information before using it as input in the bot. This was done by utilizing Stanford's named entity recognizer tagger, the NER tagger. This is quite famous model, so you can just Google it, or you can ask me later if you want to use it. Basically, it tags usernames and stuff like that as person, and then we hash them. We first parsed and used storage just for SQLite because it's fast for prototyping. We can expand on Elasticsearch or something like that. Secondly, during this period, the data collection and analysis period, we faced a lot of problems with the cleaning of the email data. Not surprising given the known 80-20 rule. Let me give just 1 second because I'm getting some else. Make sure that everyone's watching. Are you not seeing me? I think you're seeing me. Let me just continue. It has a 30-second delay. So I was in the timeline. Secondly, as I said, during the timeline, we faced a lot of problems with the data cleaning. So not surprising, given the 80-20 rule, the famous one about the amount of time needed to clean the dataset before actually deploying, evaluating, and fine-tuning your model. While we definitely did not manage to clean the emails as well as I had hoped, just imagine the different nationalities of our users around the world and the different email clients that they use. Given the 3-month timeline, we chose to pivot from not only using the email data as input, but to integrate multiple data sources, like I mentioned before, namely the documentation of the GitHub issues, which was a great idea because on the documentation specifically, the bot works quite fantastic. Finally, moving on the second phase, the DonkeyBot creation phase, the bot currently uses a question detection module, as I mentioned, which is based on regex patterns, a search engine module that uses BM25 algorithm. We could have used word embeddings, like mentioned in the first talk, from Weaviate or Elasticsearch or stuff like that, word embeddings from BERT even, but we wanted a fast prototype for starters. It also uses a question detection module, which uses BERT and DistillBERT currently. But since for the latter implementation, we're using the transformers library from Hugging Face, we can, of course, use any of the models they provide for question answering, which include Albert, Roberta, and there are probably hundreds of variations of them. I'll also be able to link you to the transformer libraries in the end if anyone wants that. So basically where we are right now, DonkeyBot is in alpha. We're on the final stage of the evaluation and deployment. We haven't tested it yet on a large enough data set to get accurate metrics. So basically, I just finished my exams in Patras. I'll now continue contributing to the project by creating a user interface, which we can use to push the bot into beta, gather more information, create a data set, and actually evaluate with statistics how it works. Now, the pipeline, a very basic pipeline. As you can see, I chose an information retrieval sort of retriever detector sort of pipeline. There are other paradigms like pure knowledge-based or hybrid approaches, but they did not apply in my project. We can see that an email, a support email, or a user query comes in as input. If the input is an email, we use the question detector module to extract the actual question being asked in the body, since the whole email is not all of it is a question. Or if the input is a user